Today we'll see few practice problem on set theory. This is first set of practice problem. Here we'll be covering introductory concept to sets, set notation, subsets, equivalent sets and equal sets. Describe the following sets in roster form. Roster form means list form as well. For set X, X is a letter before E in English alphabet. Now X should be a letter before E. That means it can be A, B, C, D. It is before E, that's why we cannot take E, and hence your answer will be just in curly brackets A, B, C and D. Now next is X belongs to N. N is natural number. X square less than 25. X is a natural number. So natural numbers are starting from 1, 2, 3, 4, 5 and so on. Now square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16 and square of 5 is 25. Now in this problem X square should be less than 25. So we can just consider the natural numbers 1, 2, 3 and 4. Here we cannot include 5 because 5 square is equal to 15 and in our question we want X square should be less than 25. That's why our answer would be just 1, 2, 3 and 4. X belongs to N such that X is a prime number and there is one more condition given as 10 less than X less than 20. That means X should be a prime number between 10 and 20. Such prime numbers are 11, 13, 17 and 19. We'll move to next question. X belongs to N such that X is equal to 2N and N belongs to N. That means that given N belongs to the set of natural numbers. Now here there is no limiting condition added to this problem. That's why this would be infinite set. Now again similar to our second problem, natural numbers are starting from 1, 1, 2, 3, 4, 5 and so on. Now this X is equal to 2N. So for 1 it would be 2N as in 2. For 2 it will be 4. For 3 it will be 6. For 4 it will be 8 and so on. And hence our answer would be 2, 4, 6, 8 and so on. Next is X belongs to R such that X is greater than X. Now for any real number, is it possible that the number itself is greater than the given number? No, it's not possible. That's why answer to this question would be phi, that is empty set, because there don't exist such number. We'll move to next question. Describe the following sets in set builder form. First is 1, 2, 3, 4, 5 and 6. Now if we observe, all these numbers are natural numbers. Hence we can write that X is equal to X is such that X belongs to N, N is natural number and this X is less than 7. So all the natural numbers which are less than 7 are considered here, that is 1, 2, 3, 4, 5 and 6. Now next question, B is equal to 1, 1 by 2, 1 by 3, 1 by 4 and 1 by 5. Now if you observe the second element onwards, the denominator of all these fractions is increasing by 1 where numerator is always 1. Now for the first number, for the first element in the set, it is 1. We can also write this 1 as, instead of 1 we can write it as 1 by 1 also. So it would be 1 by 1, 1 by 2, 1 by 3, 1 by 4 and 1 by 5. Now so can we write X as such a fraction is equal, so X is equal to 1 by N where N belongs to capital N, that is N is natural number. Now we also need to add a limiting factor such that N is less than equal to 5. Next question is C is equal to 0, 3, 6, 9, 12. Again, this is an infinite set. Now here, if we observe, first thing is 0 is also added. That means here it is not a natural number. Here it should be an whole number. Hence, we need to write the first condition as n belongs to z, and for all these z, x is equal to 3n where n belongs to z. And the last is d is equal to 0. So x is equal to, in this set, the element is x such that x is equal to 0. Moving to next question, which of the following are examples of empty set? Set of all even numbers divisible by 5. Now can we find out such numbers such even numbers which are divisible by 5? Yes, we can find out such numbers as 10, 20, 30, 40. All these are even numbers which are divisible by 5, and there is no limiting condition added, so that's why it will be infinite set with the elements 10, 20, 30 and so on. Now next is set of, and as it is an infinite set, it will not be an empty set. Set of all even prime numbers. We know that 2 is such a prime number that it is even as well as it is a prime. Hence it is also not an empty set, rather it's a finite set. Next question, x set is equal to x such that x square minus 2 is equal to 0 and x is a rational number. Now here we need to solve this equation. X square minus 2 is equal to 0. X square minus 2 is equal to 0. Hence x square is equal to 2. That is x is equal to plus or minus root 2. Now we know that plus or minus root 2 is an irrational number, and in our question it is given that x is a rational number. There are two conditions. There are two conditions given. One is x square minus 2 is equal to 0. So if we solve this, we will get it x is equal to plus or minus root 2. But second condition is also added that x is a rational number. Both the conditions cannot be true at the same time, and hence it will be an empty set, because there cannot exist such an element which will satisfy both the given conditions at the same time. Moving to next question. X is a natural number, x is less than 8 and simultaneously x is greater than 12. Now can we find out such a number which is less than 8 and at the same time it is greater than 12? No, it is not possible. Hence this set will be an empty set. So out of the given 4 sets, only question number 3 and question number 4 are empty sets. Moving to slide number 5. Which of the following sets are finite and which are infinite? Set of concentric circles in a plane. Now we know that in a plane there can be infinite number of concentric circles can exist in any particular plane. Hence this set will be an infinite set. Set of letters of English alphabet. Now we know that there are 26 English alphabets. So A, B, C, D up to Z. Hence 26 is a finite number. We can say that this set will be a finite set. X belongs to n such that x is greater than 5. Now the condition is x is a natural number as well as it is greater than 5. So it can be 6, it can be 7, it can be 8, it can be 1000, it can be infinite. Hence this set is an infinite set. And the fourth one, x belongs to r, at the same time 0 less than x less than 1. Now if x belongs to n, then we know that there doesn't exist any natural number between 0 to 1, but definitely there exist infinite real numbers between 0 to 1. Hence it is an infinite set. Slide number 6. Which of the following sets are equal? There are 4 sets given. A is equal to 1 to 3, B is equal to x such that x belongs to r, and x square minus 2x plus 1 is equal to 0. C is equal to 1, 2, 2, 3 and D is equal to x belongs to R such that x cube minus 6x square plus 11x minus 6 is equal to 0. Now we'll find out elements of all these four sets first. In the first case, elements are directly given. A is equal to 1, 2, 3. Now for the second question, B is equal to x such that x belongs to R. At the same time, x square minus 2x plus 1 is equal to 0. We'll solve this equation first. X square minus 2x plus 1 is equal to 0. Now we know that it is a square of x minus 1. Hence, x minus 1 bracket square is equal to 0. It implies that x minus 1 is equal to 0, and as x minus 1 is equal to 0, x is equal to 1. So, there will be only one element in this case, set B, that is equal to 1. Now in question number 3, C is equal to 1, 2, 2, 3. So the elements are just 1, 2 and 3. And for the fourth one, it is a cubic polynomial given. In order to solve cubic polynomial, you can use hit and trial method. If you use hit and trial method, you can solve this cubic polynomial and you will get the values as x is equal to 1, 2 and 3. Now if you observe the element, you can say that only set A, C and D are equal. Now in set C, although there are 4 elements, that is 1, 2, 2 and 3, but 2 is repeated, hence number of actual elements containing C are 1, 2 and 3, and hence set A, C and D are equal. Understood? We'll move to next. Slide number 7. From the sets given below, pair the equivalent sets. Now, in order to find out equal sets, we had to check actual number of elements. But in order to find out equivalent sets, we just need to check the cardinality of the sets. First is again A is equal to 1, 2, 3. B is equal to T, P, Q, R, S. C is equal to alpha, beta, gamma. And D is equal to A, E, I, O, U. Now we'll find out the cardinality of each set. In set A, there are 3 elements, so n of A is 3. In set B, there are 5 elements, so n of B is 5. In set C, there are 3 elements, so n of C is 3. In set D, there are 5 elements, so n of D is 5. Now, as cardinality of set B and D is equal, at the same time cardinality of A and C is equal, we can say that set A and set C are equivalent sets. At the same time, set B and set D are equivalent sets. There is a difference between the concept of equal sets and equivalent sets. Show that the set of letters needed to spell cataract and the letters needed to spell tract are equal. Now, if we consider set A is equal to letters of the word cataract, so right now this set is in the set builder form. Similarly, there is a set B with the letters of the word tract. Now we'll write both the sets in our list form or roster form. Now to find out letters of the word cataract, if we find out letters of the word cataract, we will get A is equal to C, A, T and R. Similarly, B is also equal to T, R, A and C. Now while writing the elements of sets, order doesn't matter. That's why we can say that set A is equal to set B and hence both the sets are equal sets. Slide number 9. Which of the following statements are true? Give reasons to support your answer. For any two sets A and B, either A is a subset of B or B is a subset of A. This statement is a false statement. Just an example, if at all I have A is equal to 1, 2, 3 and B is equal to AB. Now in either case, A is not a subset of B as well as B is also not a subset of A, and hence this statement is a false statement. Every subset of infinite set is infinite. This statement is also false statement. Now suppose you have a set of natural numbers which is an infinite set. At the same time you have set A is just equal to 1 to 3. Now 1, 2 and 3 are elements which belong to natural numbers. Hence we can say that A belongs to n, where n is infinite, but at the same time A is a finite set, and hence this statement is also a false statement. Every subset of finite set is finite. Yes, every subset of finite set is always finite set. So this statement is true. Next is A, B, A, B, A, B, and so on is an infinite set. Now here, in a specific sequence, A and B letters are arranged. So it is A, after that BA, after that BA, and so on. This is a sequence of particular letters A and B. So if we need to find out the elements of the sets, then it will be just A and B. So we can write set A as A and B, and hence it is a false statement that it is infinite set. Rather it is a finite set of elements A and B. A, B, C and 1 to 3 are equivalent sets. In first set cardinality is 3, and in 1 to 3 also cardinality is 3, and hence it is equivalent sets and the statement is true. We'll move to next question. Slide number 10. Decide among the following sets which are subsets of which. First question, A is equal to x such that x satisfies x square minus 8x plus 12 is equal to 0. B is equal to 2, 4, 6. C is equal to 2, 4, 6, 8 and so on. And D is equal to 6. Now in order to find out the elements of each set, we will first solve the equation belonging to set A. Now set A is equal to x such that x satisfies the equation x square minus 8x plus 12 is equal to 0. We'll solve this quadratic equation. X square minus 8x plus 12 is equal to 0. If you factorize, you will get x minus 6 and x minus 2 is equal to 0, and hence x is equal to 2 and 6. So we can write set A is equal to 2 and 6. Set B is directly given as 2, 4, 6. That is a finite set. Now set C is given as 2, 4, 6, 8 and so on. So it is an infinite set, and D is a single sentence set with element 6. Now if you observe, there is only one element in set D, whereas there are two elements 2 and 6 in set A. Then there are 3 elements in set B, that is 2, 4 and 6, and after that again there are infinite elements in set C 2, 4, 6, 8. Hence we can say that D is a subset of A is a subset of B, and B is finally a subset of C. So this is your final answer. D is subset of A is subset of B, and B is subset of C. We'll move to next question, slide number 11. Write down all the possible subsets of each of the following sets. Singleton set with element A, 0, 1, ABC, 1, 1 and 5. We'll find out subsets of each of the sets given in question. Now for the first one, it is a singleton set, so subsets will be 5 and the given element A. Second question, 0, 1. So we can have first of all empty set, then singleton sets as 0 and 1, and the given set as it is, that is 0 and 1. So in all we have 4 number of elements in the subsets. Now next is A, B, C. So again empty set, after that singleton sets with all 3 elements, then combination of elements with 2 elements, that is AB, BC and AC, and the given set. Now here this curly bracket 1 is also an element in the question. So this should be, this set 1 is treated as an element of the given set. So again, as usual, first element of the subset should be empty set. Then this one will come here. Then this one will again come here in the curly bracket and the given set as it is. Next is phi. Now this phi is there in the curly bracket. So this phi is an element. So as usual, first subset would be empty set, that is phi, and the given set is this phi. So there are two elements in the subsets of the given sets. Understood this concept? You have to study this particular slide thoroughly, where we have to write down all the possible subsets of the given set, because there is a slight variation in question number 4 and question number 5. Study them carefully. We'll move to next question, slide number 12. Let A is equal to 1, 2, 3, 4, 5 and 6, 7, 8. Now if you observe, these elements are not directly given. So set A contains set of elements, or set A contains various other sets of elements. Observe the question carefully. So 1, 2, 3 is one bunch of element, 4, 5 is another bunch, and 6, 7, 8 is another bunch. Now we'll go to question. So first question, 1 belongs to A. Now, is there any element as 1 which is directly belongs to this A? No, there is 1, 2, 3. 1, 2, 3 is a set of element, or you can say it is a bunch which belongs to A. But directly 1 doesn't belong to set A, and hence this statement is a false statement. Now next is 1, 2, 3 is a subset of A. Can we say that 1, 2, 3 is a subset of A? No, because 1, 2, 3 belongs to A, but at the same time 1, 2, 3 is not a subset of A, and hence this is also a false statement. Similarly, 6, 7, 8 belongs to A. Yes. Now this 6, 7, 8, this set is already there in set A, and hence that belongs to A. So this is a true statement. Now next is 4, 5. Now here if you observe, 4, 5 is given as bunch, and this 4, 5 as a bunch, it is a subset of A. Now if you observe in this question and this question, there is a difference. Here 1, 2, 3 are elements, and 1, 2, 3 is a subset of A. That was the question. So that statement was false. But here this 4, 5 as a bunch of element, and this bunch is considered as a set, and now the question is if this bunch belongs to A. Yes, so this bunch is there, and hence this statement is a true statement. So this bunch is a subset of A, that is a true statement. And the last one is phi belongs to A. Phi is a subset of A, but phi doesn't belong to A. As of now, have we written any phi in this set A? No. So this statement is also a false statement. You have to study this slide also very carefully, because here there is a slightly different concept, slightly confusing concept of subset, and elements of set is used with a slight variation. So study this concept carefully. Thank you. There are few more problems on sets, that those problems we'll study in next video.